Hi, I'm Mehul Shah, the General Manager of AWS Glue and AWS Lake Formation. And today with me, I have Denise McInerney from Intuit. Intuit has been a great customer and partner of ours, and today she's going to be telling us about their journey with AWS and AWS Analytics Services and how that's evolved. The right tool for the right job. Before I get started, let me introduce you to Denise. She's been working with data since 1996. She started out as a database administrator, a data analyst, and data engineer, and now is a data architect at Intuit. She's also a strong advocate for women in technology, having spoken at the Grace Murray Hopper Conference twice. And she's a leader in the AWS Community Builders program. With that, let me hand it off to Denise.
Thank you for that introduction, Mehul, and thank you all for joining this session today. So today I'm going to start by giving you a little background on Intuit's sort of data environment, how we were managing our analytics stack prior to AWS, and then I'm going to describe the migration and modernization journey that we have been on, tell you about the technical challenges we encountered, how we addressed those, and talk a little bit about the shift in thinking paradigm shifts that happened as part of this modernization journey. Intuit provides software and services to help consumers, small businesses, self-employed people manage their financial lives. Some of our flagship products are TurboTax, QuickBooks, and Mint. Now, the company has actually been around since 1983. So we started as a desktop software company where the data footprint's pretty small. And over time, we evolved into a SaaS company where our products and services were available online. And of course, along with that came a larger data footprint as our customers moved their work into the cloud. And now today, we're really a platform and AI-driven company. And the data footprint now, of course, is in the petabyte range. So over time, not only has the data grown, but of course the variety and size of the data sources we need has grown and increased. Some of them predate our journey to the cloud. But as we have evolved and as our data story has evolved, we've really seen an increased potential to use our data to better improve our products and better serve our customers. So the journey of our analytics stack kind of follows in parallel with the journey of the company and the software that we offer. And all of our analytics story was on premise until our move to AWS. So we began, like so many did, with small reporting silos, maybe a data mart or data warehouse built for one business or one functional group. And maybe there'd be one or two people who were using that to do reports and business intelligence. Our first attempt, or our first step, I should say, into big data really came with the adoption of an MPP appliance. And this was when we began to invest and bring in more data professionals. So these are folks whose job it is to analyze, to do predictive analytics, to do data science. And they were really looking to bring together all of these disparate data sources that we had so they can analyze them together and leverage them together. And of course, they wanted good performance and they wanted to be able to self-serve. So this MPP appliance was the first attempt to really serve them. And it centralized some of our data, but only a subset. So the users appreciated that data was in one place, but it wasn't everything they needed. And then we had a bit of a learning curve and journey with the performance of that particular appliance. So it was kind of a mixed experience from a user perspective, but it was the beginning of our sort of big data journey. The next phase was building a Hadoop data lake in our data center on premise. And the focus here was really on centralizing all of the data, bringing all of the data that the data consumers could need into one place. Now, the tooling there was pretty basic from a user perspective, and that reflected more or less where Hadoop was at the time. So they primarily used Hive as their interface into the data. From a performance perspective, they liked the appliance better, but all of the data was in one place, or more or less in one place in the lake, so they liked that part. So we hadn't really solved the problem for them completely, and the next step was to adopt a different MPP that was not an appliance that we still hosted, And they certainly liked that better. The experience was more familiar. The performance was better. The users tended to gravitate to it. But they gravitated to it so much that we ended up with a lot of the data in the lake also sitting on the MPP. So now we had redundancy, 2 copies of data. We had lots of raw data, and more processing started to happen on this MPP. And we could only scale it out to a certain point before we started hitting that point of diminishing returns. It was really kind of a misuse of the platform to use it as a quasi data lake, to use it as a data processing engine, as well as an analytics engine. And over time, the competing workloads of ETL and data consumers doing analytics really became a problem, right? Those competing workloads, resource contention. While the DBAs certainly worked hard tuning, you can only go so far with tuning queries when you have that sort of conflicting workload happening. And of course, the user experience was impacted by this because their resources were really constrained during the ETL runs. So we had really hit the limit of what we could do here, and it was time to take the next big step, which meant moving to the cloud. Now, Intuit's products and services, by this point, were already primarily hosted in AWS, right? So our main products were there. We had a lot of experience of migrating to the cloud, but this was the big move for our analytics story. We began with a lift and shift approach with some changes, right? So we used Amazon S3 as the storage for the data lake, but we took that same MPP and we hosted it on EC2 instances in AWS. There were some advantages here right out of the box, even with a lift and shift. The engineers, for example, had opportunities now to start POCing and using the new services. The data was available in S3, so they could begin experimenting. We could start maybe trying to use some of the other services, and we did begin some opportunistic use of EMR, which I'll talk about more in a minute. And we did have some elasticity from a data lake perspective, but from an MPP perspective, it was still hard to scale it. So the data consumers didn't benefit a whole lot from this phase of the journey. There was still those competing workloads, there was still resource contention, and we still really couldn't expand the footprint. But this lift and shift did position us to begin to leverage the power of the cloud for analytics in a way we couldn't do before. So here's a picture of what the lift and shift looked like. So reading from left to right, our data sources, right? Many data sources, that's just a picture. Moving into a data lake on S3, as I mentioned. Now I point out this Hive Metastore because it will factor into some of the journey, which I'll talk about in a minute. But the Hive Metastore is holding all the metadata for the data lake. And we have a big data lake with many objects. So it's an important component. The ETL processing, as I said, was still on the MPP primarily, and that was hosted on EC2 instances. Now, I mentioned that when we were in the data center, the users were using Hive to query data in Hadoop. So we again used Hive on EMR as a way for them to interact with the data. And the experience was about the same for them, but that was, one thing we were able to bring over. And of course, they were using the MPP heavily, as I mentioned, both for ETL and for querying. So the first phase of this modernization journey really had 3 objectives. First, we really wanted to be able to leverage the data lake better for exploration, right? We had all of the data there. Really, finally, we had met the goal of having all the data in one place. So we wanted to be able to enable exploration of that. Very important, we wanted to move that processing that was on the MPP to the left. We wanted to leverage the data lake again for that and all the services and tools available in AWS to do that. And by doing so, we could position ourselves to then move to Amazon Redshift as our MPP platform without doing the same kind of misuse of it that we had done previously. So these were the 3 objectives of the first phase. So the picture would look like this. So again, data sources flowing into the same data lake, the same Hive Metastore for the metadata. But now in the upper right, these are the ETL processes, right? So Amazon EMR, big part of that, and AWS Glue. And I'll speak to both of these more in a minute. On the lower part of the diagram, now we can use Amazon Athena for exploration of the data in S3. So the users can connect to Athena for that. And then, of course, they would still connect to Amazon Redshift for analytics data warehouse type workloads. So this is the picture at the end of the first phase. So let's walk through each of these objectives and our experiences with them. So first, leveraging the data lake for exploration. So at this stage, the MPP is still the primary platform for the users. We still have 2 copies of things, right? 2 copies of raw data, one in S3, one in the MPP. But the scale out problem was still there, right? And we weren't making the most of what was available to us. Now, the user's experience of querying the data, remember, in the lake was only through Hive. And from a performance perspective, it was not a good experience. They were not enthused about this being the tool. And it's definitely not the same experience as querying an MPP, for sure. So we chose to leverage Amazon Athena for this use case. It's purpose-built for querying S3 data interactively. Of course, it's serverless, so the engineering team did not have to manage infrastructure. You get a lot of elasticity and scale out of the gate. However, this is the first place where that Hive Metastore factors in. It wasn't integrated initially with the Hive Metastore. And we tried a number of ways to work around this, and they just didn't scale. We have a very large data lake, we have many, many data consumers, and we just couldn't find a workaround to this that would work for us. Now, however, at reInvent 2019, an important new feature was announced for Athena, which is Athena integrating with the Hive Metastore. This was a very big deal for us, and we had partnered with AWS on this feature prior even to the preview being announced. The integration of Athena with the Hive Metastore, it made wide adoption of Athena at Intuit possible. It was a very big deal for us. So now we have the tool, right, and we can use it. But we still had an important use case that we haven't solved, right? So we've got raw data in the lake, but of course the MPP is still hosting a lot of aggregated and curated data. And a very common use case for the data consumers is needing to be able to join these 2 data sources. So now, the only way we could enable that initially was by taking copies of the curated data from the MPP and copying it to S3. So now we again have data redundancy. This time it's redundancy of the processed, curated, aggregated data, 2 copies. And of course, anytime you do that, there's delays in delivering it. There's a burden on engineers because they have to manage all those jobs in order to make that data available. Another important feature comes into play here. So again, at reInvent 2019, the Athena federated query feature was announced. And this enables Athena to query other data stores besides S3. And there are a number of connectors that came right out of the box when that preview was announced. Unfortunately, connector for our MPP was not one of them. But there is an SDK. And this was another place where we collaborated very closely with AWS in order to produce a custom connector by using the SDK so that we could have federated queries between S3 and our MPP. And from a user perspective, it was quite simple to use, right? So they needed to join data between the 2 data sources. I have an example of the code there on the slide, pseudocode. All they had to do was reference the name of a Lambda function in front of their schema.table name for the data stored in the MPP. And everything else sort of happened magically to them behind the scenes. And the performance was really good. We got excellent performance the way this was implemented. So this enablement of joining data between the 2 data sources was a huge boost to adoption because many, many data consumers had this specific need. So this was the second way we were able to leverage Athena in a really big way to use that data lake for exploration. And here's a picture of what that looked like. So the users issue the query to Athena, same as ever. They don't know what's happening necessarily. Athena takes the portion of the query pointed to S3 data and sends it to S3 as normal. The portion of the query that needs the MPP data goes through this Lambda function, goes to the MPP. It executes that portion of the query and sends the results back out to S3, actually. If it's a case of a join, the 2 data sets come together and Athena presents the results to the end user. So quite transparent to the end user, very powerful feature. So an MPP can hide a lot of sins in maybe queries that aren't written so great or tables that aren't well tuned, it can be quite forgiving. Queries on S3, maybe not so much. And so this was the next sort of challenge that we faced in both thinking differently about how we tuned these queries and understanding what was happening under the covers a little bit. So when you're querying data in S3, you are not querying a database. And what's really, really, really important when you're querying big data stored in S3 is how that data is partitioned, right? And you have to understand when you're doing the layout, you have to understand how the data is going to be accessed by the consumers and partitioned accordingly. And so we went through a bit of a journey here. Very important that we work with the data consumers to understand their access patterns so that we could lay the data out in a way that was useful for them. Other side of the coin is people writing queries have to understand how to use those partitions. So how to even know what the partition keys are, and then how to use those partitions within their queries. And the two sides came together here. This was a very important learning journey, I think, for everybody, but we made a lot of progress here. So this is the performance went from not so great to really very fast once we got the partitioning right. The other thing we ran into was sort of our conservative approach initially. There's a lot of concern about cost management. And so Athena allows you to restrict how much data is scanned in a single query. And we had set that quite low. And the users ran into it quickly. So they're trying to run queries and they kept hitting this error message. So what we did there was, now that we had a little experience and we'd partitioned the data better, we got examples of real queries against the largest data sets. And we ran those and saw, hey, how much data would you legitimately need to scan as a consumer of this data lake? And then we set the scan limit accordingly. And of course, that eliminated the error message, but also put us in a position where analysts, data consumers now had confidence that they'd actually be able to execute their queries. And we just keep an eye on the cost. And thus far, it has not been a problem. So those two things were important learning curves for us in terms of the nitty-gritty adoption by the end users. And I've mentioned the users a lot, right? To be successful here, you really have to bring your customers along, right? This was a lot of change for them. If you think back on how I walked you through that journey of everything we did on-prem, there have been a lot of migrations, right? We'd made a lot of changes that had disrupted their lives. And from their perspective, on the surface at least, everything worked on the MPP, right? They knew how to use it. It was one place. All the data was there. It was relatively fast, although it got slower. But the truth is that using that MPP for everything was really not such a great answer, right? It did get harder and harder to scale it out. I mentioned that mixed workload resource contention problem. That resulted in delays for them getting access to the data, right? Because they could run their queries. And so by sort of walking them through and explaining how the from and to would be better for them, training them on the tools, right? You got to give support, right? You're asking them to adopt a new set of tools and really partnering together with the data consumers, we were able to deliver a much better experience for them. And there were definitely some benefits once they sort of got the hang of it. One example is that data landing in the data lake was now ready immediately. They didn't have to wait for it to get moved. And they could just open up an Athena query and hit it right away. So as soon as the data was written, they could access it. But you have to sort of walk through and explain these things and really partner with your customers when you're making these big changes. All right, the second objective we had, right, was to shift that processing off the MPP and move it left. Move it to the data lake and leverage these other services available. So let's talk a little bit about our experience there. First place we started was Amazon EMR. Obviously, Spark is really core to big data processing workloads. And some of our team did have experience with Spark prior to the move to AWS because we did have Spark available in our data center on our Hadoop data lake. So it was a good natural first step. And we tried to be opportunistic, looked for projects. As projects come up, would this be a good way to try out EMR? And there were a couple, right out of the gate, there were a couple that were really good fits. So that was a good opportunity for us to start using this service in a serious way. Of course, like with all platforms, there's a learning curve, right? You have to learn how to use it. You have to learn how to tune it. So tuning those Spark jobs, right-sizing those clusters, right? Figuring out what instance types to use, how big they should be, how to get that sweet spot between price and performance. Partnering with AWS also very important here, right? They certainly know their services, and they gave us very good advice on how to approach this. So I would say over the first 6 months, 6 to 9 months of this, number of people on my team got quite adept at this tuning piece and cluster sizing piece by working with AWS as well. So that was our first foray into shifting processing left, and of course, a lot of our processing now runs on EMR. But there's also a paradigm shift that came with this, right? I mentioned a minute ago, S3 is not a database. And so when you're thinking about moving your processing off of an MPP into an S3-based data lake, you have to think differently about your jobs and about how you're going to do things, particularly like changes to data, upserts, because you're not updating a row in a database, right? You're rewriting a file, and that can be expensive. So it's really important that you understand the mutability of the data in question in a given data pipeline and plan your jobs accordingly. Think about things like the file size and the partition keys again, right? And really shift how you're thinking about how you would manage a job in an environment where it's not a database. Don't just assume it's going to behave the same way, because it will not. Again, partitions, right? You're trying to find that balance because at the end of the day, if you're writing a result that is going to be consumed by data consumers, you want those partitions to be optimized for that consumption. So you have to balance what might be best for your ETL job against what might be best for your data consumer. And I would argue that you lean into what's best for your data consumer, because they will be reading that data repeatedly, whereas you'll be writing it maybe once a day, once an hour, whatever it is. But nothing comes for free. It's always a balance, right? Like all tuning, it's always a balance. All right. Now, the next AWS service that we began to leverage to shift the processing left was AWS Glue. And of course, this was a little different. We didn't have any experience with this on-prem because it's an AWS service. So we were kind of starting from ground zero. And it was important for us to think through how we could integrate AWS Glue into our environment, where it would fit, where the touch points are that we might have to address. And one of the engineers in particular on the team really dug into this. She looked at all the places where a Spark job would have to fit and the other services it would have to interact with. So for example, we have an internal security service, which our jobs have to interact with. And so figuring out how that integration was going to work. Again, the Hive Metastore. So integration with the Hive Metastore was another obstacle or another challenge we had to address. There was a file compression type we were using that didn't work right out of the gate. And so that had to be addressed as well. So between our engineer and our team really digging in and understanding the service and already having an understanding of our environment, and again, collaborating closely with the AWS team to expose these challenges, these new use cases perhaps that they hadn't encountered before, and help think through solutions, not just workarounds, but actually brainstorm solutions. And a number of new features came out that enabled us to really adopt AWS Glue in a bigger way because these challenges had been addressed. And so again, we looked for opportunistic ways we could leverage the service initially that maybe didn't have these particular obstacles in front of them. And then as those features got released, we were able to do more. So again, the theme here, right, is work with your AWS partners, particularly if you have an environment like ours where we had a number of pre-existing services that we had to integrate with that weren't, greenfield out of the gate cloud services, cloud-based services. So it was really great to see that level of collaboration as well and see those solutions come out. So to wrap up, look at the objectives that we had and what were the benefits that we saw as we went through this phase of the migration and modernization journey. Well, first, talked about the data lake for exploration. What did that mean? That meant less data movement, less delay in getting the data, and therefore the data consumers being able to do more work with the data. More analysis could be done, less productive time lost. Shifting that processing left Well, a number of benefits there, right? You get scale, you get elasticity, you get a wider variety of tools, less latency, jobs run faster, data is available sooner, and all important, getting rid of that resource contention on the MPP. You remove the resource contention, you get more productivity from the users of the MPP because they don't have to wait for those ETLs to finish. And now, finally, we were set up to migrate to Amazon Redshift. So what are the benefits there? Well, the managed service, integrations with other AWS services, the elasticity of your data warehouse on a cloud-based service. All of those things gave us a lot of benefits. So throughout this journey, we had to shift our thinking, right? We had to all of us develop new skills, the engineers, the data consumers. But by adopting the right tools for the job, we've really been able to accelerate what we can do with analytics. Thank you so much for your time and attention today. I really appreciate it. And if you would, please fill out your session survey. Thank you.